the semester is starting now. It did not start back in.
The classes will commence from next Monday, 7th.
Oh, I see. This is because of the COVID situation, I guess.
Yeah, everything is delayed.
Right.
Everything is delayed. ఇంకా ఇక్కడ తెలంగాణ కొంచెం ఆందోళన ఇంకా అది కూడా ఇంకా మొదలు పెట్టలేదు ఇంకా.
Oh, really?
ఈవెన్ NITs కూడా ఇప్పుడే స్టార్ట్ అవుతున్నాయి. NITs, IITs.
అవును, ఇన్ని రోజులు ఆన్లైన్ కూడా లేదా అసలు? there is nothing.
ఫస్ట్ ఇయర్ అడ్మిషన్స్ లాస్ట్ వీక్ క్లోజ్ అయినాయి NITs.
Oh, I see.
Except deemed universities, all are delayed. All government colleges, affiliated colleges, universities. Only deemed universities మాత్రం ఆల్రెడీ సెమిస్టర్ అయిపోతుంది, డిసెంబర్కి అయిపోతుంది వాళ్ళకి.
Oh, wow. Okay. Yeah.
వాళ్ళు అడ్మిషన్స్ ఎట్లా చేసేస్తున్నారు. గవర్నమెంట్ కంట్రోల్స్ ఏం లేవు కాబట్టి వాళ్ళు ఓన్గా చేసేస్తున్నారు.
రైట్. ఇప్పుడు మొత్తం ప్రోగ్రామ్ అంతా డిలే అవుతుందా, లేకపోతే సమ్మర్ లో కవర్ చేస్తారా? నెక్స్ట్ సమ్మర్ లో, పైన సమ్మర్ లో అలాగా?
సెకండ్ ఇయర్ అయిపోయేసరికి కవర్ అవుతుంది. 2 years లో అవుతుంది ఇది. ఈ ఫస్ట్ ఇయర్ ఆగస్ట్ అయిపోతుంది. నెక్స్ట్ సెప్టెంబర్ లో స్టార్ట్ అయితే అది అట్లా 2 years కి స్ట్రీమ్ లైన్ అవుతుంది. ఇఫ్ ఎవ్రీథింగ్ గోస్ రైట్.
I see.
Okay, Satish, thank you. Raju, please go ahead. It's 1:15.
Madam, please introduce Satish sir.
Yes, sir. Good afternoon, everyone. I'm Gautami Koruri, Assistant Professor, Automobile Engineering Department. Now, I would like to introduce our session speaker, Dr. Satish Makkapati. We welcome you, sir.
Oh, thank you. My pleasure.
Thank you, sir. Dr. Satish Makkapati, a leading researcher in the field of automotive powertrains, received his PhD degree in mechanical engineering from West Virginia University in 1997. He joined Ford Powertrain Research Laboratories after graduation and continues to work at the labs in Dearborn, Michigan. In his current role, he serves as a technical expert in powertrain performance, fuel economy, and durability attributes of Ford's EcoBoost lineup of engines, and manages the powertrain and vehicle simulation group that helps develop next generation engine technologies to meet government regulations and customer satisfaction. Dr. Makkapati has deep experience in analytical and experimental analysis of all aspects of internal combustion engine design, including thermodynamic, thermal, and structural. He has written several journal, conference papers, and holds multiple patents in this field. Over the years, he also has taught mechanical engineering courses at the University of Michigan and Eastern Michigan University. He enjoys teaching robotics to middle and high school students and prepares them for various championships. He enjoys running for health and well-being. We welcome you, sir, and we are so fortunate to have you for this session. You can start the session, sir. Thank you.
Thanks, Gautami. Hello, everybody. My name is Satish Makkapati. Let me share my screen. Are you able to see my screen?
Yes, sir.
Please let me know when you're able to see my screen.
Yes, sir. We can see the screen, sir.
Okay. I want to make sure you see one window, not a main screen and a split screen. Are you seeing the single screen?
Yes, sir.
Okay, good. Thanks. Okay, so what I wanted to bring to this discussion is the automotive propulsion. So first of all, I appreciate everybody trying to be in the automotive field. This is a really good time to be in the automotive field. In fact, the last few years have been really interesting, and I think the next few decades will be even more interesting. The whole area is kind of exploding with so many new directions. So it's certainly a very exciting time to be an automotive engineer, and I'm so glad you're all you have taken interest in the automotive field. I'm very confident you'll find this very interesting and engaging in the future. So all I wanted to do today is to bring attention to the automotive propulsion for the most part. Obviously, by propulsion, I mean things that move the automobile, right? So whether it is propelled by a conventional internal combustion engine, or if it is propelled by an electric motor, nonetheless, propulsion, right? So I want to bring to your attention some trends that are happening in the area. So there is a little bit of an introduction that I would like to do. But first, let me give you a summary of what these are the big main takeaways, I would say. I would like you to understand these at a very high level. I know most of you are coming into the field. You do not have much exposure to the details of the technical details. I guess you do not have sufficient background yet, but I want you to understand some concepts at a very high level, and I think that will be very helpful to you, I think. So there are 4 items that I pointed out here. The first one is the automotive propulsion advanced tremendously over the last 120 years. I think automobiles have been around for a long time, and people have been perfecting them over the years. So the automotive propulsion is significantly advanced, and we have made a lot of gains, improving the efficiency of the engines, and also making them clean so that we don't produce any pollutants from the engines. That's the one main takeaway. And then the second one is, in the last couple of decades, we have seen significant amount of hybridization of the automobiles. By hybrids, I think most of you probably understand what hybridization is. It is using a combination of propulsion methods. So it is using, let's say, the internal combustion engine and an electric motor to drive a vehicle. When we do this, we get further advantages. Whatever we have been able to do in the first one here, we can combine the advantages of that with electric motor to improve the overall system efficiency. So this hybridization essentially moves us forward in terms of how effectively we can propel the vehicle. And the third one is, even though we have been able to do all that, we have significant challenges in meeting carbon dioxide regulations going into the future. So this is another one that is a key item, and this is driving a lot of new development, and all the new directions are driven by the third point here. We have to meet the CO2 regulations, and why do we have to meet it? I will show you in the next few slides what the issue is. But this is driving a lot of new directions. And the last one is, I think the last maybe decade, 2 decades, I would say, there has been a significant amount of interest in developing autonomous vehicles and smart mobility. Obviously, these are connected, right? So there are so many new things. Everybody has a cell phone, and connectivity is all over the place. And because of the connectivity and all the new sensor development that happened over the last couple of decades, the autonomous driving and smart mobility have become very, very popular or emerging topics in the automotive industry. So this is the fourth one, I would say. So it's basically, if you get these high-level points, I think you'll understand where the automotive industry is going as far as propulsion is concerned. I'm not going to talk about a lot of other things that are related to the automotive industry, but for propulsion, these 4 points are important, and I will keep coming back to this as we go forward. So the agenda is, I will introduce, why do we need to worry about climate change? This is the big driver for the new propulsion directions. And this drives all the electrification that we see at the moment, and I will explain to you, why that is so. After that introduction, I will go into some details around what is the current state of propulsion and where are we going in future. It's mostly around how do we create the most efficient engines? How do we make sure that they're very, very clean so that they don't put out any pollutants? And then what is the electrification? How is the electrification coming into the picture? So that's part of the propulsion. And then I will go into a very small discussion, I would say maybe 2 or 3 slides worth of discussion into smart mobility, connectivity and autonomous driving. And you'll see why the automotive field is so dynamic these days. Okay, so let me start with the introduction. I have a few pictures from a long, long time ago. This is 1894 AD, and these are the streets of New York. As you can see, there are so many wagons that are being drawn by the horses, right? So you see all these horses that are driving the wagons on the streets of New York. And then you also see very, very busy bridges and things like that. But the bottom line was in 1894, there were 150,000 horses in New York City alone. Just in New York City, there were that many horses that were pulling everything around. The problem with the horses, obviously, is they produce a lot of waste. So somebody has to clean up all the roads. And then they get tired and they need to be fed and they need to rest. So there is, if you look at how somebody would want mobility, there are many pain points here, right? They create a lot of waste and they cannot function all the time, and they're also only capable of, each horse is capable of 1 horse essentially, right? So this was the state in 1894, and there has been a lot of research in the combustion engines at this time, and people have been inventing the internal combustion engines, both gasoline and diesel. So by 1903, Henry Ford came out with his Model T. Model T is this vehicle that you see here. It was producing about 20 horsepower, meaning that the vehicle was capable of equivalent to 20 horses pulling your wagon, right? And it weighed about 1,200 pounds, and it could go up with 30 miles per hour speed. And obviously, the automobile did not get tired, so you can continue to use it as much as you want. And it is a lot more capable than a single horse. So this was a major, major development, obviously, in transportation. So if you go back to, again, the picture from 1894 AD and the New York streets, in about 25 years or so, those streets have become like this. All the horse wagons were replaced essentially by automobiles. So you see a streamline of automobiles now essentially taking the place of all the horse wagons. Of course, as time went on, then automobiles became, the volume of automobiles and the roads have become so vast. So now you see, at the moment, you see conditions like this where there are traffic jams for, I don't know, 12 to 15 lanes of traffic jams, and all these vehicles are on the road. So the problem now is every one of these automobiles are using some sort of fuel, whether it is gasoline or diesel. Gasoline is basically petrol. So petrol or diesel. And all these vehicles are producing some kind of pollution. And I can talk about what pollution is, but it is easy to understand that when you have so many vehicles on the road, you have to make sure that these vehicles are running as efficiently as possible, because they're all consuming crude resources. And so therefore we need to make sure that we conserve the crude resources and protect the environment. Both of those things become very, very important. So with this many cars on the road, there are big challenges on the climate side. So this is some background on, if you look at the CO2 concentration in the atmosphere, and there is a lot of data. This data goes back to the year 1750, right before the Industrial Revolution. And you can see how this data shows a trend here, right? There is the left-hand side y-axis is the atmospheric CO2 concentration. These are parts per million. So the pink curve shows you that the concentration was around 280 parts per million back in the day. And then it stayed fairly flat, but then you can see this increasing trend. It is now the concentration is settling around 420, 450 parts per million, which is significant increase from 250 years ago. And on the right-hand side, you see the CO2 emissions from, the CO2 emissions from vehicles and all the human activity, I would say, not just the vehicles, but the CO2 emissions that are created by humans. And if you see the trend, we were not creating a whole lot of CO2 prior to the Industrial Revolution. And then you can see a very clear trend. And the automotive explosion, so to say, I guess, with so many cars on the road, the CO2 production by those vehicles is significantly higher, and that is driving the overall production of CO2 per year. This is billions of tons, right? So in 2020, this projection is around 40 billion tons of CO2 that is being pumped into the atmosphere. So when you're pumping so much CO2 into the atmosphere, then obviously the concentration goes up, right? The parts per million go up. And so what is the consequence of this increase in CO2 in the atmosphere? The consequence is obviously global warming, because CO2 is a greenhouse gas. It retains heat, and obviously the atmospheric temperatures go up. So the right-hand side plot shows exactly that. The x-axis is the year. You can see from 1880 to 2020, and the red curve shows the temperature. So the temperature, as you can see, the curve is sort of flat, and once we have the CO2 emission production by humans, then this curve starts going up. And what does this mean? If you look at the y-axis for the degrees Celsius, we have raised the atmospheric temperature by 1 degree Celsius in a span of about 60 to 70 years. Clearly, this trend seems to be just going up. There is no settling or coming down. This trend is just going up one way. And that is a big problem for global warming. And so that is the climate part of the story. Because we are creating so much CO2 from our automobiles, this temperature rise is unsustainable. We cannot just keep going on this path. We are already seeing some evidence of global warming with the sea levels rising and so many other climate patterns changing and things like that. So what happened was in 2016, a lot of countries, more than 170 countries, they met in Paris for this climate conference. So in Paris Climate Conference, they agreed that they will try to limit the global temperature rise to less than 2 degrees Celsius. So we already increased it by 1. So we have the path that we are going on now. We can only afford to add another 1 degree or so, before the consequences become very disastrous. So if you look at this climate meter here, pre-industrial average. So let's start with 0, and then right now we're 1.1 degrees warmer compared to the pre-industrial average. And then if we don't do anything, the way things are at the moment, we're at a risk of moving that temperature rise to 4 degrees, which really has disastrous consequences on climate. So the Paris Accord essentially is trying to limit that damage. So we at least don't go to 4 degrees, but we try to settle down at 2 degrees at most. The aggressive estimate is, we can go up to 1.5 degrees, but that seems a little too optimistic. But 2 degrees is a realistic goal. And a lot of the countries have signed on to it. It is obviously, it's non-binding. It's a voluntary thing. People are trying to come together and make a difference for our Earth. These are not enforceable, but everybody is trying to do their part. So as part of that, Ford Motor Company and other manufacturers, they're all committed to this goal, and they want to do everything they can to try to make sure that the climate change does not get really bad. So with that in mind, what does that mean for the automotive industry? Essentially, what it means is that if you look at the CO2, this is a different scale now. This is tracking grams of CO2 per kilometer. So every kilometer that the vehicle drives, how much CO2 it produces. Right now, in 2020, the average is around, let's say, 150 grams of CO2 per kilometer. That's where we are now. The goal is to drive that down all the way to 0. So by 2050, we would like to be completely carbon neutral, meaning that we will not emit any net CO2. We will not put any more CO2 into the atmosphere from vehicles. That's the goal. So we have about 30 years or so to become completely carbon neutral. That's the goal. The problem is, well, the goal is nice, but there is really no real way to get there at the moment. See, we primarily consume fossil fuels at the moment. We get all these fuels from the ground, petrol and diesel and everything. And as long as we get them from the fossil fuels and burn them, we will produce carbon dioxide. And there is absolute limit. There are limits under which you cannot go, realistically speaking. So this is, the goal is to go to 0, but as long as you're burning fossil fuels, we really have no way to go. So that is a key takeaway, meaning that because we don't have a way to get there using fossil fuels, we need an alternate way to become carbon neutral. And what is carbon neutral? I will explain that in the next couple of slides. But just understand that we really have no way to go there. As long as we're burning petrol and diesel in our vehicles, we just cannot get here. And that's the problem. That's what drives this electrification trend. We need vehicles that do not consume fossil fuels to get here. And that is what is driving the real industry trend. Okay, I hope that's clear. And then the CO2 production. Okay, so why do we actually, how do we produce CO2 in the vehicles, right? So I took a very simple example. This is an example of combustion of methane. Just, any combustible hydrocarbon, let's say, just for illustration, because it's easy to explain the reaction. Gasoline is a lot more complex in terms of the molecules. So I don't want to go into the gasoline combustion because that creates a lot of compounds and a lot of complex reactions. So for methane, so when you burn methane, obviously it's an exothermic reaction. It releases heat, and you use the heat to expand gases in an engine to produce work, right? So you get that exothermic reaction and you get the heat, but the products of combustion of methane reacting with oxygen is you create this carbon dioxide and you create water. And is that everything that you create? No, you also create a lot of pollutants. You create some levels of nitrous oxides because air, obviously we don't have pure oxygen. We're taking in air which has nitrogen in it. So some of the nitrogen at high temperatures reacts with oxygen to make some nitrous oxides, which are poisonous. And sometimes we don't get, a lot of the times, we don't get complete combustion. We get some intermediate products like carbon monoxide, which is, again, poisonous. We also get some unburned hydrocarbons. We also get smoke. These are literally carbon particles. So we get all these pollutants, and for the longest time, this is all the industry worried about. All the governments worried about the pollutants that are harmful, that can actually do some damage if you were to ingest those pollutants. So this is where most of the concentration was, and as an industry, we have become really, really good at cleaning up all the exhaust. So if you look at the tailpipe emissions these days, there are regulations, very strict regulations from government. They track, how much of nitrous oxides are you producing, and how much of these unburned hydrocarbons are you producing, or the smoke that you're producing. And they say the vehicle has to be in this teeny tiny bound here, like the SULEV, we call it. It's a super ultra low emissions vehicle. It is getting to a point where it's actually getting very difficult to even measure this concentration in the exhaust anymore. It is that clean, right? So we've gotten really, really good both for petrol engines and for gasoline engines. We can really clean up the exhaust. So this is not a problem anymore. Right? We can clean up the pollutants with the technologies we have. The problem is this: there is really no way to avoid carbon dioxide, right? That's one of the products that's a product of this combustion, and it's always there. It gets produced as long as you're burning hydrocarbons. And this CO2, again, like I showed you in a couple of slides ago, as long as you're producing this CO2 and pumping this into the atmosphere, then you're creating this greenhouse gas condition and obviously global warming, right? So what do we do? This is almost like an existential threat for humans at this point. We have to find a way to take out carbon dioxide from atmosphere. There's just one more concept that I quickly want to touch on, the brake thermal efficiency. So this is basically if you were to put some fuel into the engine and you burn and you get some work out, what is the energy content in the fuel that went into the engine, and how much work did you get out? So let's say you put so many kilojoules, let's say 1 kilojoule of energy in the fuel that went into the engine. And if you only get 0.3 or 0.4 kilojoules back, then your thermal efficiency is 0.3 or 0.4, right? That's the definition of it. And one way to reduce the CO2 is if the engine is very, very efficient, then you don't need to consume as much fuel. So therefore, the CO2 production automatically goes down. So that's why we spend a lot of time, over the many, many decades to improve the efficiency of the engine. So we can get more miles per gallon, and also we can reduce the carbon dioxide that's being released. So the higher the thermal efficiency, the lower the carbon dioxide emissions. That's one aspect of it. So going back to this condition where I said, okay, what do? We want to go down to zero net CO2, but we really have no way to get there because we always produce CO2. So what do we do? So the answer is this. This is the goal. This is how at least Ford wants to get to carbon neutrality by 2050. The idea is we don't actually take energy from the fossil fuels. We get the electricity from renewable resources, right? We get it from wind and solar. So as long as we produce electricity from wind and solar, we can take that electricity, and then if we have electric vehicle, then obviously the electric vehicle can take the electricity into the battery, and then obviously the vehicle drives, so there is no problem. We don't produce any CO2. There is going to be a lot of excess electricity because unfortunately electricity cannot be stored very effectively. We have to put it somewhere. So what we can do is to take that electricity and run electrolysis on water, and this process produces hydrogen, and hydrogen is a fuel, right? So hydrogen you can use in a fuel cell vehicle, or you can actually burn hydrogen in an internal combustion engine as well. It's a fuel, and when you burn hydrogen in an internal combustion engine, because there is no carbon involved, you don't produce any CO2. Right? This is pure hydrogen combined with oxygen, and it produces water as a product. There's no CO2 involved. So that's a reasonable thing to do. The other things that we can also do is we can capture the carbon from atmosphere. So there is a carbon capture technologies, the many technologies. You can capture the carbon dioxide from atmosphere, and that captured carbon dioxide, you can do a couple of things. You can do what is called carbon sequestration, which is storing all that CO2 underground so that it's not polluting the atmosphere, or that CO2 that you harvested from air, essentially, you can combine that with this hydrogen that we got from electrolysis, and you can create something called e-fuel or synthetic fuels. They're called multiple ways. But these fuels are like the regular hydrocarbon kind of fuels. So you can take those fuels and then you use them in a vehicle, much like we are doing now with petrol and gasoline, petrol and diesel. We can burn them in our vehicles, and they produce CO2, obviously. But that production of CO2 is offset by what you're taking in up here, right? You're harvesting CO2 from atmosphere during this carbon capture process. So that whatever you're taking out from the atmosphere, you're putting back into the atmosphere here, but that's offset. So again, you come back carbon neutral. I hope that makes sense. The whole idea is to make sure that we are not pumping any more CO2 into the atmosphere, and there are many ways to do it. And this here is driving all the future trends. How is that so? Obviously the big part of the story is the electric vehicles. So now we are seeing lots and lots of electric vehicles. Every manufacturer is producing electric vehicles, and they're making the electric vehicles a bigger portion of their portfolio overall, so that they can become carbon neutral at some point. And there's a lot of research that's going on in the fuel cell area. Fuel cells, again, they consume hydrogen, and in the fuel cell, hydrogen reacts with oxygen, and it makes electricity, which you can again use to drive the vehicle. But this is a clean process. There's no CO2 involved in these steps. So those are the things that are driving a lot of interest in electric vehicles and the fuel cell vehicles, and making the conventional engines as efficient as possible, so that we can also reduce CO2 that way. So I'm hoping all that's making sense so far. Why we are discussing these things at this point. It's all around the carbon neutrality. We want to become carbon neutral by 2050, and these are the enablers. Okay, so what does all this mean? I'm just going to check, quick time check. We have another 25 minutes. Okay, so what does all this mean? In the near term, we must create the most efficient internal combustion engines as much as possible. And we know how to do that, and I will show you some examples of how we actually do this. And then we increase the penetration of hybrid electric and full electric vehicles into the market. So if we replace some of the conventional vehicles with hybrid vehicles or the full electric vehicles, then that's good for the net CO2 production into the atmosphere. The long term, as you've seen from the previous slide, we definitely want to move towards the electric vehicles and fuel cell vehicles and the internal combustion engines that are running on synthetic fuels or the e-fuels that I described in the last slide. So that's the overall big picture, and then this will let us go to the carbon neutrality in the longer term. Okay, so back to my agenda. So that's the background story on the climate change. And now the propulsion side, what is the current state and what is the future? So I talked about efficient engines and how we are doing that now. And the emission side, I won't say a whole lot. This is, like I said, we've become really, really good at taking out all the pollutants. These emissions really are around the pollutants, not so much about the CO2. I won't speak too much about that, but let me cover this efficient engines part. I know a lot of you are just getting into engineering. There's probably not a whole lot of exposure to thermodynamics, but the big thing that I just wanted to point out is there are limits to how much energy you can actually convert in an engine. Engine is an energy conversion device, right? It's basically taking the chemical energy from fuel and it's kind of converting that into mechanical energy. But due to the laws of thermodynamics, you cannot convert all of the energy in the fuel into work. You always have significant amount of losses. And there is a lot of theory behind why that is so, which I will not go into. But basically, there are limits to what you can do. And there is, starting from even a very, very ideal scenario, you can only convert 70 to 75% of the energy. A more realistic scenario is 50 to 60%, but the practical numbers are in the 25 to 35% range. And in the best case, if we are able to hold the engine at its best operating point, the speed load point as we call it, you can get 40 to 45% of the energy converted. So it's like, if you invest $100 into it, you only get $40 to $45 back from the engine. So the internal combustion engine by nature is not a very high efficiency energy conversion device. That's the problem with it. If you look at the typical electric motors, the amount of energy that goes into electric motors as electricity and then the mechanical energy coming out, the motor efficiency is 90% plus, right? It's able to convert 90% of the electrical energy into mechanical energy. But in the gasoline or any of these engines that I'm talking about here, the efficiency of conversion is very poor. And that's part of the reason why we have hybrid engines. Because it's also, even though we know ways of maximizing the brake thermal efficiency, we cannot always run the engine at such a high efficiency point. That's when we try to use the electric motors to compensate. Whenever the internal combustion engine is not efficient, we use the electric motor. And when the internal combustion engine is efficient, then we use the internal combustion engine. And as a combination, we create a hybrid engine that's much more efficient than just the internal combustion engine. I don't know if that is a difficult concept for some of you, but that's the concept behind it. And I'll come back to that one more time in the next few slides. But back to the thermodynamics part of it and why we have these inefficiencies. There are a number of losses that happen in an internal combustion engine, and energy goes into these losses. There is energy lost to, we lose heat from the combustion chamber. So that's energy just literally walking out of the engine. And the working fluid that we deal with, it's not particularly efficient. It retains heat essentially. Because it retains heat, then again, that heat again goes out the exhaust. That's a waste. And there are a few other mechanisms. Let's get a little bit more deeper into exactly how the energy gets released from the fuel, and how much of that energy is being captured is determined by how big these losses are. If these losses are big, then we don't capture as much efficiency. Let me skip that and go into maybe keep it at a slightly higher level. But like I said, there is 120 years of development, right? I mean, we've been working at this for a long time, and we have nearly perfected the art of getting everything possible. I mean, there are incremental opportunities still this is a very active research, and we can continue to improve the brake thermal efficiency of the engines. But we've been at this for a long time, and as an industry, we've made a lot of progress. And the complexity of the engines that we produce right now, it's almost mind-boggling. It's got so many hundreds of parts. Everything comes together in a very seamless fashion to make the engine. And the engines have to, like I said, produce the best efficiency. And for that, let me play this video. And I have a couple of videos. I'll play them quick. You may not understand everything from it. I just want you to get a flavor for what the engines look like. Okay, so yeah, like I said, I don't expect you to understand everything, but that gives you a flavor of what happens in an engine and how we try to take out these inefficiencies as much as possible using a lot of technology. So in that perspective, I just wanted to show you this graph in terms of how much we improved over the last many years. So if you just track the last, what is this, maybe 40 years or so of development, you can see that this purple curve, it shows the emissions, that net emissions, these are the pollutants. And you can see these pollutions pretty much came down all the way to zero, right? If the reference was 0%, we came down like 100% from there. And these are very near zero at this point. And this green curve, you can see the vehicle efficiency going up by almost 100%. And performance-wise, we're able to get a lot more performance, like the horsepower per liter from these engines as well. So we've been making tremendous amount of progress over the last many decades. And part of the reason why we have been able to do that is we have become really good at simulating these engines. So we don't test everything these days. We don't test all the engines in hardware. We test them in software, right? We have softwares that can simulate the thermodynamics and the fluid mechanics and the heat transfer and everything. And we can replicate, essentially, we can create a virtual copy of the engine in software, right? So we are doing a lot of simulations on the computer to refine these engines before we ever produce a physical hardware and test. And we do the same, we do the engine simulations, we do the vehicle simulations. We are trying to understand what improves the overall system efficiency. So this is very important. I think these are some of the things that you learn as you go forward in the curriculum. And at least you will learn all the engineering behind it, I would say, regardless of the specific software exposure. But you'll have the background to do all this in simulation. And just to add a little bit more flavor to it, like I said, the internal combustion engine operation is extremely complicated in the sense that engine is spinning at, let's say, 3,000 RPM or so. We have 25 cycles at 3,000 RPMs, meaning that 25 times per second, we have to inject fuel, burn it, extract work, and the next cycle starts. You do that 25 times in 1 second. Just imagine the complexity of doing that, getting everything to perfection. So we can do a lot of that in simulation again. When do we want to inject the fuel? When do we want to spark the air fuel charge? A lot of those things can be done again in simulation, and that's one of the reasons why we've been able to make such tremendous progress in optimizing these engines in the last few decades. We can understand not just from the performance side, we can also understand durability side. How hot is the engine getting? You can look at the temperature distribution. You can simulate all this. You can figure out the temperatures in the cylinder head, for example. It's 272 degrees Celsius. You can make all these predictions in software, and that really helps to fine-tune the design and optimize the design as much as possible. So we do finite element analysis. In the previous slide, I showed you we do thermodynamics and gas dynamics. And we can also look at the coolant flow. So this is a liquid flow inside the engine. We can simulate this. So that's the progress. And I'm trying to say, Srinivas, I have to stop at in about 12 minutes, 10 minutes.
Yeah, right, 2:15.
2:15,
okay. 12 minutes.
About another 12 minutes, okay. So let me skip some of these things, maybe. Okay, so maybe just a quick concept. I think I tried to explain this a little bit in words. This is the brake thermal efficiency of the engine on the y-axis, and this is a load on the engine, meaning that how much, if the engine is capable, let's say, of 100 kilowatts of power, if you ask the engine for 70 to 80 kilowatts, it is very efficient. But if you're asking the engine for only 20, 25 kilowatts, it's not very efficient. That's just the nature of the engine due to many different losses that happen. So the concept with the hybrids is, because the engine is efficient, when we're asking a significant amount of power from it, we try to keep the engine here as much as possible. And down here, when the engine is not very efficient, we can use the electric motor to drive the vehicle. So we use a combination of electric vehicle and the internal combustion engine so that we can get an overall system efficiency that's better than just running the internal combustion engine. I just wanted to give you a quick idea. This electrification, hybridization is not one thing. There is many levels of hybridization. We have something called micro hybrid, then mild hybrids. So this is roughly this kind of scales with the voltage that we use. Micro hybrids are at 12 volts, mild hybrids at 48, and the full hybrids are all 300 volt plus systems. But even the full hybrids, they come in different flavors. If it's just a full hybrid or a plug-in hybrid, basically this is a hybrid that you can connect and charge at home or at any charging station. Whereas these, you cannot have any external power, electrical power going in. The plug-in hybrid can take in some electrical power, and you can charge up the batteries, and then, but it is still a hybrid. It still has an internal combustion engine in it. So all these four variants have the internal combustion engine in it. The last one, what is called BEV, battery electric vehicle, this is completely a full electric vehicle. So this has no internal combustion engine in it. And this is the newer vehicle. Ford just came out with a new model this year, just went into production. But most of the industry is doing that. Everybody has an electric vehicle these days. They're just coming out with it, or have just come out with it, or going to come out with it in the near future. But Ford has presence in all these different levels, and we try to use the different levels of electrification, and over a period of time, we try to go to the carbon neutrality that I was talking about. I will skip some details about what the hybrids do in the interest of time. But if you look at the industry as a whole, so you can see that 2015, starting from 2015, and this goes only up to 2030, but you can see the distribution of vehicles. And these are all the OEMs, right? These are the Hondas and Toyotas and Fords and everybody together. In 2015, most of this space, this is all conventional vehicles, right? No, not hybrids, not electrified vehicles, and very tiny sliver of hybrid vehicles. But as time goes on, by 2030, you can see the conventional engines by themselves is a smaller portion of the overall portfolio. All these companies now have significant amount of HEV, which is a hybrid electric vehicle, and PHEV is a plug-in hybrid electric vehicle, and ZEV is a zero emissions vehicle, as it's called, but it's also the battery electric vehicle, or it can also be fuel cell. But you can see that the portfolio, the mix in the portfolio is changing as time goes on, and that's the whole point. Going back to, again, the previous product that I showed you, with the grams of carbon dioxide per kilometer, and how we want to be carbon neutral. So, we are at 2020, and we are sliding on this glide path. So not everybody is going to just stop producing all the conventional vehicles and then switch to electric. That's not going to happen. So, but we go down this glide path, as we call it, to become carbon neutral by 2050. It doesn't mean that at 2050 we won't have any internal combustion engines. It doesn't mean that at all. What it means is that we will figure out a carbon neutral way of doing it. So, like I explained in the previous time that I showed this, we will have a combination of electric vehicles, fuel cell vehicles, and the internal combustion engines in the mix. Together, we try to drive down the carbon to zero by net carbon to zero 2050. You may still have some carbon dioxide coming out from the vehicles, but like I said, it's offset by what is being taken out of the atmosphere by the carbon capture process. Okay, so that's that. That covers the climate change aspect of it, and what are we doing on the propulsion side with our efficient engines and electrification. Couple of quick slides on the smart mobility, and then I will try to end this on time. Smart mobility is the absolute craze in the automotive industry at this point. That is the reason why I said the automotive industry is so exciting. The engines, we know what we're doing, but the mobility side is all new, and it roughly goes into two categories. One is called the ADAS, Advanced Driver Assist Technologies. So the newer cars have all these different sensors on them. They can sense the vehicles if there are vehicles in the front, they can sense them. There are cameras that are also looking in the front at other vehicles in traffic. There is protection all around the vehicle. There is 360 degrees cameras. So with all these, the point is to make sure that we can assist the driver as best as we can. So the driver doesn't have to, even if the driver is not completely concentrated on driving, the car can make some decisions. If it is approaching another car too fast, then it can actually brake. And it can take so many actions to avoid some collisions. So that's the driver assist technologies portion of it. And then there is a connectivity portion of it. This is the brand new thing. The vehicles all the new vehicles have modems in them, and they're able to connect to telematics and what is called V2X. That is a vehicle to X is anything. X is like a vehicle to another vehicle or vehicle to a house, or the vehicle can actually talk to traffic lights. Vehicle can be in communication with the network. And if there are people on the streets, the vehicle is aware of it. The vehicle essentially has become intelligent in a way because it is connected. It is connected to everything around it. It's not a dumb vehicle anymore. It can actually you can say it can see and do things. Right? That's the connectivity part of it. And it's also connected to cloud. So it can send some information to cloud, and from cloud, information can go to all the places, or it can receive some information from the cloud. Anyway, so between these two, the driver assist technologies and the connectivity, there are a bunch of new growth areas. So traditionally, this used to be automotive space. There is internal combustion engine and materials and manufacturing safety. But now all these new things have come into play, and that is the explosion of the automotive industry: electrification, connectivity, ADAS, data analytics, artificial intelligence and machine learning, compute architecture. The new vehicles literally have 40 to 50 computers on them, microcontrollers on them, right? Each vehicle. But a lot of this revolves around these all enable the autonomous driving in one way or the other. And there are various levels of autonomous driving. And the industry is going more and more autonomous. As you go from left to right, you will see higher level of automation. Maybe I don't know if I can cover this in detail, but essentially we're trying to go from this level 1, where the driver is operating the vehicle actively, and to a driverless scenario. This is a complete automation. So the driver is not even there. As you can see, the driver is missing. The vehicle does not need a driver anymore. It can be completely functional on its own. So if you think about everything the way it is going, then there is this vision that the city of tomorrow is going to look very different than what it is now. And there's a short video. I'll play this, and then that'll end my presentation. All right, that's an advertisement for Ford, but let me come back to my summary. This is how I started. If you recollect, I said we made a lot of progress on the automotive propulsion over the last 120 years. And this is a conventional engine, and then we hybridized it and made it even more efficient overall at the system level. But even at that, we cannot meet the CO2 regulations as long as we use fossil fuels. So we have to become carbon neutral, and I explained that. And then all the new stuff around autonomous driving and smart mobility, and there's so many new things that are upcoming. It's a very, very dynamic area, and I'm really glad that a lot of you have chosen to be part of this field. Okay, I'll stop there. Srinivas, I don't know if there is time for any Q&A, any which way you want to take this from here.
Yeah, just few questions are there. Just let me take 2-3 minutes. Gautami, please, we can proceed. Gautami, are you there?
Ma'am, can I ask? Go through that.
Yeah, one moment, sir. Yes, sir. Sir, we have few basic questions from our students.
Yes. I'm sorry, I'm not able to hear anything. I'm not sure if somebody is asking anything or not.
Sir, question is this. Sir, which engine is best, diesel or petrol?
Which engine is best? So diesels are inherently more efficient than petrol engines. So there is lot of subsidization that goes on in several parts of the world, particularly in Europe. The governments encourage everybody to use diesel because it's more efficient than petrol. But it depends on the usage. Actually, depends on the markets. In the U.S., the diesel engines are there is no subsidization, and the fuels are more expensive. And traditionally, the diesel engines tended to be a little bit more producing pollutants that got produced from diesels in the past. Not anymore. I mean, they're very clean now, but a few decades ago, diesel engines tended to be a little bit more pollutant producing, I would say. So the US industry is primarily petrol. European is primarily diesel, and there are good reasons for both of them. But in general, the diesels are more efficient, if that is the question.
Yeah. Thank you, sir. There is another question, sir.
Yeah.
If we upgrade to electric vehicles, even the battery manufacturer produces more CO2 and other gases. So then how do we overcome this?
Yes, excellent question. So that is very true. That happens. So there is a concept, what we normally call well to wheels concept. So if the battery electric vehicle is not producing emissions when we are running it, that's only what we call tank to wheels, which is basically, yeah, at the vehicle level, it's not producing anything. But during the manufacturing process, whether it is manufacturing the batteries or the vehicle itself, it does produce some level of carbon dioxide. And there's no way around it at this point. But the idea of carbon neutrality is that if we create some carbon dioxide when we are producing, then we have to take it out again during carbon capture. So as long as whatever we're putting into the atmosphere, whether it is during manufacturing or other processes, we have to have ways to take it out so that we can become net carbon neutral. So when Ford talks about carbon neutrality, Ford is not talking carbon neutrality just at the vehicle level. It's also talking about all the manufacturing included. So we have to find a combined way of being carbon neutral. That is a good question.
Thank you, sir. And last question, sir. It is about consumption of diesel depends upon engine or what, or any other parameters like that.
Yeah, there are a few reasons why diesel is more efficient. Diesel actually has, if you look at the energy density of diesel, it's a little bit higher than gasoline. So for the same volume of diesel, you get naturally there is more energy in it. That's one reason. And the other reason is there are losses that happen in the gasoline engine because to control the power that we produce from the gasoline engine, the gasoline engine has to run at something called stoichiometry. We always have to maintain a certain air-fuel ratio, which means that when we want to produce lower power, we have to restrict the air from going into the engine. So that creates what is called pumping losses. So that happens for the petrol engines, but diesel engines don't have that problem. You do not have to run stoichiometry on diesel engines, and you can run very, very lean, which is not an issue, so you don't incur pumping losses. So there are differences like that, and diesel combustion tends to be overall less hot, so it doesn't release as much heat. But diesel has other problems. Diesel pollutants, treating the pollutants from diesel engines is a lot harder than treating the pollutants from a petrol engine. So we end up investing a lot of money into what we call the after treatment systems. So everything that comes out of the engine needs to go through a lot of after treatment to get rid of the pollutants. So there are advantages and disadvantages to both. We cannot say one is definitely the winner over the other.
Thank you, sir.
Nope, definitely.
Yeah, those are all the questions, sir. And thank you so much for your time, sir. Like at this odd moment, you came here.
4 a.m.
Yeah, it's 4 a.m. I think so.
Yes. Oh, no problem. My pleasure.
Thank you so much, sir.
Yeah. Okay. Yep. Thank you. I'm signing out then. Yep. Bye-bye.
Thank you, sir. Yes.
Okay, students, now you will get a feedback link in WhatsApp group. Please give the feedback. Okay, and don't post done and yes completed, sir. Please don't post these messages. Why? Because you guys are missing their important information. Why? Okay. Okay. From now onwards, please don't post these information. Done, completed. Yes. Okay. Thank you, ma. Sir, even September.
Thank you, Satish. Okay, he left. Okay. Right. Raju, you can go ahead.
Okay, sir. We'll continue.
I think he has left. Satish has left. Okay.
Yes, sir. Yes, sir.
Yeah. Right.
Okay. So the next session will start within 5 minutes. Before that, please give your valuable feedback. Madam, feedback link post.
him?
Yeah. Sorry, sir. 2 minutes, sir. They are giving feedback. Please, 2 minutes. Okay.
Yes, now we have like further session on VNR differentiators by Suresh, D. Suresh, Assistant Professor, and Pavan Bharadwaj, Assistant Professor of Automobile Engineering. Yeah. Suresh sir, you please start the session.
Thank you, ma'am. My voice is audible clearly?
Yes, sir. Please share your screen.
Okay, ma'am. Thank you. Good afternoon to one and all. I am D. Suresh, Assistant Professor in the Department of Automobile Engineering. I have 5 years of teaching experience, and I am associate with the Department of Automobile Engineering from 2016. Currently, I'm doing my Doctor of Philosophy in VIT University, and I have done my Masters in VIT University in collaboration with the Automotive Research Association of India. I would like to thank head of the department for giving this opportunity to introduce myself to you and to execute and to introduce the VNR differentiators to you. And first of all, I would like to say all the best to all and congratulations to all to be VNRians in the future. Basically, these VNR differentiators will provide a new way to approach any kind of learning. Basically, if you see in engineering education having a motto to make a students they can solve the dynamics, what are the problems which are there in the society and problems, society, industry and economy. So any engineering education will make the students in that aspect. In this particular aspect, the VNR VJIT has a philosophy of making made in a philosophy of an outcome based education. So this outcome based education is achieving uh, through the development of variety of internal processes which can help the students when they are graduated, which can help the students uh, when they are came out of the campus, they are completely having skills of modern engineering education. So in that particular aspect, these VNR differentiators is developed by the institute will be categorized into three different categories. That is experimental learning methodologies and participative learning methodologies and project-based learning methodologies. This project-based learning methodologies and prospective learning methodologies and experimental learning methodologies uh, will come across when you are coming to the class, maybe regular class work, as well as when you are come across the lab. So if you see an experimental learning methodologies, that is learning by doing, that is one way, and VNR lab protocol, storyboard, and prospective participative learning methodologies, it will be included in the classroom, that is Whitwill and show and tell and POGIL activities. And you will learn by doing in a project, that is course based projects or maybe weekend projects, or maybe by doing your internships and industry oriented mini project. So this in a short time I would like to introduce some of the most attractive learning methodologies like we often come across in every semester. Those things today just we will introduce me and Pavan Bharadwaja. So that is VNR lab protocol, storyboard, and Whitwill and course based project. So now I would like to go first VNR differentiator, that is Whitwill. So in and study sessions by the HOD and some of our faculty also mentioned, they gave some abbreviations maybe for wit and will. I think you remember that. That's why I am teaching and what I am teaching, which stands for, and will stands for why am I learning and what I am learning. So if you see the wit, why I am teaching and what I am teaching is for the teacher's perspective. So the teacher will take care of by putting these two questions, why I am teaching and what I am teaching. He will prepare the, or maybe he will deliver the lectures. And the student's perspective, he need to do why he is learning and what he is learning from the student's point of view. This kind of exercise will be doing in the classroom. So basically, in which perspective, what faculty will do? So each faculty will prepare one scenario which will correlate your entire syllabus with the real world problems which you are facing at the outside. So that is, before dealing with any particular topic, in a that particular faculty will correlate that particular topic to the real world scenario and explain that one uh, to you. So that not only for in a particular content, entire syllabus is mapped to the real world scenario, and he will explain the problems out the outside and what is the solution in our syllabus. So he will map those two things and he will deliver the lecture. For an instance, just now that Banu also quoted about the infotainment and telematic systems is comes into the picture, and vehicle communications levels are increasing. So these are some of the advanced technologies are available to increase the security and safety in the vehicle. So in that particular concept, we in our curriculum we have one particular course, that is automotive infotronics. For that particular course, one of our faculty is developed the uh, scenario, so that now I will just show it, then you can understand about that. For example, the scenario name for that particular course is a for that particular course, one particular topics is a road accident. So generally we are seeing at outside the road accidents are occurring due to the human problem, human mistakes, or maybe sometimes out of control of the vehicle. So in that particular concept, if you see the different kind of accidents which are taking place outside, generally we saw, for example, if you see the statistics related to that, around by uh, what are the different ways of the deaths occurring due to the road accidents, I categorized as the percentage in Indian context. So now you can see when they are directly hit vehicle to vehicle, there is a one type of collision, or maybe sometimes the side collision, and sometimes when you are crossing the pedestrian collisions suddenly, and night time due to the lot of vision, lack of vision, there is a collision, and sometimes when you are moving on highways, side collisions. Okay? So when you are overtaking some vehicle, and sometimes if you are able to hit by hitting an accident at the time, so due to the injuries, internal body uh, subjected to hit to the vehicle body, the death is occurring. So sometimes you can see when the pedestrian is hitting on that. So in this particular concept, if you see the road accidents now I am shown. So in this particular picture, when the accident is occurring, this one is restraining it. This is called airbag. You know the term airbags and seat belts. This is restricting the passenger depth. And similarly, there is one other airbag. This is also restricting the pedestrian accidents or maybe injuries to the person which we occurred the accident to the pedestrian. And sometimes we are creating the lane vision concepts, or maybe by creating the proper illumination. So and sometimes we are creating the lane assisting systems, and we are developing anti-lock braking systems and traction control systems. So these are the different ways we will with these technologies we are avoiding the accidents. First we saw what are the different ways of road accidents and what kind of technologies we have in our syllabus to whatever the technologies are available in the vehicle to avoid the accidents. So this we covered in the syllabus, unit 4 and unit 5. You can see. This way we develop the content, develop the scenario and correlate with the syllabus. Similarly, another concept which we vehicle robbery. So in the vehicle robbery, how many ways the vehicle will be robbed? So the first, by removing the door, vehicle that is vehicle car door, and he will theft, or maybe he will rob her. Or sometimes he will maybe give another copy of key and he will theft the vehicle. And sometimes he will unlock the steering, or maybe unlock your start your engine, and he will theft the vehicle. And sometimes he will do see, there are different ways will be there to theft your vehicle. In order to avoid this by opening of this door by a person, or maybe some any other external usage, we have developed the keyless entry system. That is one concept. And another, we have an engine immobilizer. That is one of the technology we developed. And another, we have steering lock. So these are the different technologies now I mentioned, which are already there to avoid the theft of the vehicle. even though this many technology he breaks and he will tap the vehicle. Another thing is we have is the wheel lock. Even though he removed all these barriers, still we can lock the wheels, or maybe tire lock we can do. And another technology, even though he can tie, when we are developing all these technologies, one thing we have, the only one option he has to tap the vehicle is carrying by on his shoulders. So still, if we carried the vehicle through his shoulders, still we have a GPS navigation systems through which we will identify the vehicle where it is, where the robbery, where the vehicle is there. So this is one way. So in this way we covered the syllabus, unit 2 and unit 5. This is just an explaining one particular subject, how they develop the scenario and how they correlated with the syllabus. This is about the wit. So as a student's point of view, they need to see, as this respective faculties develop one scenario, so as same way the student has to develop one scenario in his own perspective, and he need to question themselves, why I am learning and what I am learning, and he need to implement whatever the learning things are there, maybe in terms of the projects, or maybe creating another scenario, or maybe concepts or anything. You need to correlate them. So that is the Whitwell concept. And the lab course projects, the names itself is saying, when you are enter into a lab, basically they will allot some projects to you, and the projects will be, maybe they may form the groups according to your interest, the respective faculty, and allow maybe allocate some projects. You need to work on those projects. So the respective faculty will give the list of projects to you, and you need to choose one of the project, and you need to choose your group, and the respective group of people on their interest, they need to choose the particular course project, and they need to perform according to their due dates. So that's about the lab course project. Just these are the some of the projects which are given by, which are developed by the students in automotive chassis laboratory. So this is a demonstration model of disc brake for bike. So in the bike, so this developed by the students as a lab course project. And this is also one demonstration model of car suspension. So this is also done by the students. And this is also demonstration of torque converter. These are the different kind of projects we develop in automotive chassis laboratory. Every year we come across this kind of demonstration models around 8 to 10 according to the students interest. The faculty will also encourage, depending upon the scope of that particular laboratory. So you need to perform the lab course projects, this having some kind of weightage to your curriculum point of view, and at the same time this will give some scope to you learn about how to know the basic engineering basics. What you learn your first years and second years, you can apply through these projects and enhance your knowledge. This is my opinion on these two things. Now hand over the session to the Mr. Pawan Bharadwaja. He can take care of the VNR Lab storyboard. Thank you, one and all.
Hello students, good morning, good afternoon. Thank you Mr. Suresh sir for taking a fantastic session. Myself Pawan Bharadwaj, I am the assistant professor in the Department of Automobile Engineering. I have been working in this college for 5 years, and I am associated with SAE projects like Baha and Supra. Today I am here to explain you about what is VNR lab storyboard and lab protocol. We have two things called lab storyboard and lab protocol. These are very important and very significant aspects of the differentiators, where each and every experiment that you conduct in the laboratory will be related to the real world scenario. Like, see, the Department of Automobile Engineering itself is the branch where you directly connect with the vehicles. Like, you can directly, any concept can be connected to the real world within just a matter of minutes. So this storyboard is one of the aspect where you still go in depth and connect it with the um, real world scenario. Let me tell you, yeah, this is what is lab storyboard. First of all, yeah, it is aimed to make the students understand what is happening in the real world and how our experiments. See, you will be getting a doubt. See, if I am doing one experiment, so why should I do it? So there you will be knowing, okay, if I am able to conduct this experiment, the product which is available in the market, there is some other product. So that is how you are going to apply this experiment in the development of the product or in the R&D of the product, like that. for sample purpose and for your understanding, I'll just give you the explanation of automotive electrical and electronics laboratory. See, I'll just why we have chosen automotive electrical and electronics is because these days automobile is full of electronics and electrical systems, already a session has been given, an interest has been given around electric vehicles, I think. So this lab is one of the major lab where you connect each and every topic, like each and every sentence, you can connect it to your real world scenario. So here if you see, there are different, you can see the, I think you can see my screen. So there you can see automotive electrical and electronics laboratory storyboard. So this storyboard is indicating different experiments and how these experiments are going to be are connected to the real world scenario. So real world scenario for automobile engineer is always a four wheeler. In general we consider a four wheeler. Only in specific conditions we will be considering a two wheeler and a more trucks. So in this one, in lab storyboard, what we'll generally teach is like we'll just show you the different equipment we have and how we are going to apply this equipment, how this equipment will be helpful for your real world applications. First of all, let me come one by one. This is something called battery charger. Yes, battery charger. Most of you have seen asking questions regarding electric vehicles. Some of you were asking questions. So if you are looking into that perspective, battery charger is one of the major equipment. No need to give a brief explanation also. Without having a battery charger you cannot do anything, right? For an electric vehicle, even for an IC engine there is a battery needed, right? There is a 12 volt lead acid battery placed in a vehicle, in a two wheeler or a four wheeler or even a six wheeler. So this battery charger is used to charge that vehicle. This is a servicing equipment. Okay, this is not a it's servicing testing equipment, it is a servicing equipment. With this one we will be charging the battery and you will be finding out how much current. We will be showing you how to do quick charging, how to do slow charging, and I'll show you that can be learned here. Next is electrical test bench. This one, the green one, is an electrical test bench. This is the fantastic equipment where you can test the starter motor and an alternator. See, everybody will be using a bike and a car at least. So there, early morning, what you will do whenever you are going to start a bike, you will be using yourself. Okay, but in general it is called self, but the technical term for that is a starter motor. So this one, the black one, is a starter motor present here. So we are going to check how much current and how much voltage the starter motor is going to take from the battery. So is battery sufficient enough to start the starter motor? Maybe in sometimes your starter motor might not be working, but your horn will be working. That means your battery is not capable of taking that much amount of voltage. So here we will be checking, okay, what is the status of the battery? Like even for a lead acid battery, with this test bench, we will be checking what is the status of the battery, whether is it capable of giving that much voltage and current so that your engine starts. Okay, if not, then we'll be doing the things accordingly. Next is an alternator testing. So alternator is, yeah, it is used to charge the battery. So if at all there is any problem with battery, we'll check with the alternator. Okay, is it charging the battery, or battery is able to take the charge first of all. So this is these kind of things. Next is a spark plug cleaner and tester. If for a petrol engine you need a spark plug. So here we are going to check whether the spark plug is in good condition or bad condition, or if it is in bad condition, we are going to clean this and we are going to apply this. These are the electrical systems. Next, you can see there are automotive sensors. See, automobile has as many sensors as any other product. Automobile is having around 50 to 60 sensors placed, and they are running at a time. Simultaneously, 10 to 50 sensors will be running. So that is why I have told you automotive electronics is very, very important, and that is the feature. Feature is totally with automotive electronics. So for that one, there are different sensors we have seen. We have seen a display. Here we have a displacement sensor. We have a temperature sensor. We have a load sensor. We have speed sensor. Okay. So we are going to here in this lab, what you are going to do, you are going to take the input from the sensor and you are going to apply it and convert it and see in the system. So the sensor is giving some temperature, right? So that you want to see in the system. Okay, so that you are going to do. And apart from that one, there is training module for MPFI petrol engine, how a petrol engine these days is working. Okay, instead of carburetor, you might be knowing from BS6, all vehicles above 125 cc are having petrol engines. Sorry, injectors, fuel injectors. So how injectors are going to work? So does it have an what are the sensors it has? So here there are wide list of sensors placed in this module. The moment you come into the college, you can jump into my lab and you can check out what are the different sensors placed in this board and how you can use those sensors. And there is a, apart from that, there is wiring layout also. Like this, there are different equipment in each and every laboratory which are very well connected to the real world scenarios. That is called lab storyboard. Next, I'll just quickly move on to the lab protocol. What is a protocol? So here I have shown, we have shown you how these are connected. But in lab protocol, how in will be, it will be little bit specific, like it will be little bit in depth to the extension of the lab storyboard. It is an extension of the lab storyboard. So here you will be checking out each and every experiment and see how this experiment is connected and what you will be doing. See, for starting, before starting any lab, you will be a session will be taken for you exclusively on lab protocols, how you need to conduct the lab. So what are the equipment you have in the lab and how these are going to applicable. Okay, what is the purpose of doing any experiment? Okay, you are not going to do simply, right? So anything that you are going to learn is definitely is going to be you need to impact that in the industry or wherever you work. That is the motto. So we are intended to teach in the same way. So I'll just give you brief explanation of same electrical and electronics lab protocol. So yeah, these are the objectives and outcomes what you are going to learn in this lab. There are different objectives and outcomes. Skipping on to this, I'll just skip to the list of experiments. So what are the experiments you have? You see, first one, electrical wiring system. First one is electrical wiring system. You study what how the wiring happens. There is a light. There are different electrical devices, right? There are lights, horn, okay, wiper motors are there. Okay, apart from that, there is an ECU that doesn't come under electrical system, that comes under electronic system. So there are different electrical and electronic systems. We see how wiring is going between these three things. There is different color coding happening. Okay, that and all will be explained here. Next is electronic fuel injection. As I said in the earlier slide, electronic fuel injection is something which is very predominant these days. So we'll be checking and demonstrating how a fuel injection happen. You can actually see the fuel spray. Okay, there is a glass jar available in the lab. So there you can see the fuel spray, how fuel spray is happening, which is very rare actually. After that, battery maintenance and charging, how to charge the battery, how to maintain the battery, which is the major area where we need to work out. Huge amount of R&D is going on in this area. Next is starter motor testing and starter motor and alternator testing. Next, ignition system. These 5 experiments are of electrical systems and 5 experiments are of electronic systems. These are of different sensors. These sensors I am not going into depth because you should learn the theory, and maybe you are not aware of different sensors. Might be you might be aware of a speed sensor or a crash sensor, but these are a little bit of technical terms. uh, okay, so after this one, like this, see, this is the wiring layout. So this is the wiring layout. We have wiring layout of a alto, where there are different systems. You can see lights are there, horn is there, wiper is there, starter motor is there, alternator is there, and spark plugs are there. You can see the dashboard, old dashboard of alto is also present here. So in such a way, we are going to explain. This is in a similar way. If you are doing for each and every experiment, then that completes the lab protocol. Yes. So like this, we are doing for each and every experiment. This is for a MPFI system. Here, I think you can see there are different sensors available. These are the different sensors, and here there are spark plugs. As I have told you, here you can observe the spray pattern, how a spray is happening. These are fuel injectors actually. If you come to the lab, we can show you how spray is happening, how spray is happening in our engines. Okay, it's a 3-cylinder engine. Obviously, it is also an Alto engine. So apart from this, we will be having, yeah. Apart from this, we will be having the starter motor and alternator testing that I have shown you. So this is the equipment where we test alternator, starter motor, and battery. So next is very important experiment, control of a DC motor. You see, most of the electric vehicles these days are having electric motor. So you need to know how to control the electric motor. Without knowing control of electric motor, there's nothing doing. So you will be learning how to control an electric motor and how there are different control strategies. Okay, control techniques are there. So that we will be teaching you, and you will be doing it in live. So after that one, you have different automotive sensors, and you are going to interface all these sensors. See, any sensor you cannot see it just directly. Okay, it's not like your thermometer. Okay. You need to interface that with the system, and you need to do something. Conversions has to be done, analog to digital conversions and digital to analog conversions has to be done, and that then only you are able to see in the computer. If somebody is knowing about OBD for every vehicle, there will be something called OBD, onboard diagnosis system. So there, these days, some OBDs are coming with USB ports also, like premium vehicles. There, if you just plug in your USB port in the OBD and you can read out the sensor data. Mostly, the sensor data is not open for normal person. This will be open only by the industry people. So once, so that is like, if you can read OBD, then it is great. So in that OBD, all the sensors data will be there. If you are capable of understanding how a sensor works, then you can find out really what a sensor is doing there. Where is a fault in the system? If you are into R&D, you can see how these sensors can be applied, and you can make a new product also by taking all these inputs. So this is about a quick interaction or an overview on lab storyboard and lab protocol. With this, I am going to wind up the session. Thank you very much for kindly holding back and listening to the session. Yeah, if you have any questions, you can shoot up quickly. After that, you will be having a fantastic session on SAE activities that are happening in the department. It would be more interesting and more engaging. Please shoot the questions quickly. Sir, Raju sir, any questions, sir?
Pavan sir?
Yes, madam.
Yeah, thank you so much. Yeah, there are no questions, sir.
Yeah, and then I think Dr. Venkatramana sir will take over from here.
Yes, sir.
Yeah. Thank you very much.
Yeah, thank you.
Hello. Hello.
Sir, can you start with them, sir?
Okay, right. Good afternoon, dear students. This is Dr. M. Venkatramana, Professor of Automobile Engineering Department. I have been working in the institute since 2003. I did my BTech from VR Siddhartha Engineering College, Vijayawada, and MTech from NIT Warangal, and PhD from JNTU Hyderabad. So I have more than 17 years experience in VNR VJIT. Basically, I'm going to teach for you, especially with manufacturing related subjects. And also, I have an experience with other subjects like engineering graphics, power plant engineering, instrumentation, etc. Good afternoon once again. So this is a little introduction about myself. So before my session, Mr. Pavan has told about exciting session about SCAE. So actually, what is SCAE? SCAE means Society of Automotive Engineers. If you see, in every college, there are different engineering branches are there, and each engineering branch will have its own professional society. So SAE we call as a professional society. And similar to that, ASM is there, IST is there, but automobile engineering is looking after SAE club or SAE student chapter also we call. So this is a logo created by our students, SAE VNR VJIT. And you can see there are different logos are there. That means there are different events organized by the SAE society. SAE society, different events organized every year at different locations. You can see SAE India Baha, SAE Supra Student Formula, and Formula Student Event, etc. So every year at different locations, these events will be organized. From different states or different colleges from the India will participate these events. So you can see here, this SAE society or chapter established in the year 2011 in our college, and our students very actively participates in the following events like Baha SAE India, Supra SAE India, Formula SAE Japan, Go-Kart Championships, Formula Bharat, SAE Student Convention, etc. So you can see there are different photographs at different locations where our students or your seniors have participated. And one of the good, okay, there are different achievements are there. We'll see in the coming slides. Okay, so this is in a lab we call as SAE laboratory. So this is our special. No college is having a special lab for fabricating in a vehicle. So our management and institute has created a separate space for you or for the students, those who are interested and can stay back and can work in the lab with their ideas, or you can work with your projects to make your dreamed car or dreamed vehicle as per your requirement. We will provide the facilities, and there are different facilities are also available, so you can make use of those facilities. So this is a car which was fabricated by the students. You can see in the photo, and this car was participated in a JSAE competition at Japan in 2011. So this is in the same car at location, in the Japan location. You can see our students, your seniors, and in continuation in Japan. Okay, in 2012 also your seniors have participated the same event in the next year, that is in the 2012. So these are the different pictures, and this is all together all the participated vehicles in 2012 at Japan. Our vehicle is also there. Yeah, you can see there our vehicle. So this is a news clip. And this is a Supra event. Our students have participated in 2013, and you can see here a person from R&D Honda, that is Mr. Numato, visited our college for the placement, and he was interested to ride our vehicle. So he driven the vehicle and given the good appreciation to our students, and one of our students has got selected for his placements in R&D Honda. So this is another event at Coimbatore. Your seniors have participated in Formula Fierce Formula event at Coimbatore in 2015. So these are the different pictures, and this is the logo of our SAE student chapter, especially for Fierce Formula. And you can see here one of the video. So the vehicle is riding in our institute. So next video, and you can see after fabricating, we need to test the vehicle. So initially we are testing with the chute in our college. So this is another vehicle that is participated in the Supra 2016 at New Delhi. And this is all-terrain vehicle participated in the event Baha SAE India 2017. So this is a team where they are working in the lab. And this is another event. So these are the different stages of a vehicle, where initially we model it, and then we go for analysis, and then we fabricate and testing. And now you can see a small video. So this is all-terrain vehicle testing in our college. So initially we started with, or your seniors have started with the modeling. And there are different levels of testing will be there. Once all the tests pass, then only you are eligible to ride the vehicle in the race. So before completion of testing, you are not allowed to test, your vehicle will be not allowed on the tracks. So that's why there will be different test will be there. So after passing all the test, then only your vehicle allowed to test on the track, or allowed to move, or allowed to ride on the road or on the track. And you can see this another testing is taking place during the participation in the event. So these are the different vehicles fabricated by our students and exhibited in the Open House 2018. So Open House is a event that takes place every year in our college. So where the good projects will be displayed. And this is another event participated in the Formula Bharat 2018. And this is the location. So this is Buddha Circuit at New Delhi. The students are participating. And you can see right side. Okay, our vehicle is there on the track, but the picture is very difficult to find out, but our vehicle is there on the track. You can see this is one of the tests we call it a skid pad. So once this okay, so due to lack of time, we are unable to play some videos. So these are the different events every year our students will participate. So a team consisting of first year, second year, third year, and final years, so that the knowledge sharing will take place from the final year to third year to second year to first year. So that once you come to the final year, so you can lead the entire team with third year, second year, and first years. So this is another event fabricated recently and participated in 2020 Baja event. So this is another event. Yeah, this is Aero Design Competition Challenge 2020. So you can see a small aeroplane-like thing. So that is also we fabricated in our college and participated in the event. You can see our principal and our director there. So we are receiving the best paper award from the event organizer that is published in the SAE journal. Best paper award we received. So these are the different projects. You can see this is an e-bike, electric bike that is made from the cycle. And our principal is riding that vehicle. Foldable electric vehicle. So you can fold it and you can keep it in our car. So wherever you want to take it, you can take it. And from there, you can utilize that foldable electric bike. So we are receiving the award for that from the So this is another car, micro car. This is also fabricated as a part of the project, final year project. And the students are receiving the best gold certificate from IIA International Innovation Center in 2019 for the project called Electric Micro Car. So this is hybrid electric bike fabricated by students as a part of their project. And this is a metal 3D printing. This also is a part of the project students have fabricated. So thank you. Just before winding up, so what is the need of participating and fabricating all these vehicles and events. The main motto is you will get subject knowledge and group leading knowledge, and how to lead the team, and how to participate in the event. So all these things you will get the skill. Actually, you will get the skill development through this project, and at the end, there is a scope for good placements in the core companies. Good placements in the core companies. Recently, one of your senior, Naveen, has got a placement when he participated in one of the event like this. So that is the main intention of this event. You can see now a small video of your senior who has placed in the company through these events.
Sound issue is there.
And now it's clear. You can play. So is Mr. Naveen ready? Recently
Sir,
passed
we'll
out
skip this.
student.
We'll skip this.
Okay. Okay. So that's all, or anything is there, Krishna?
Okay, sir. Complete.
Okay. So, okay. All the best, my dear students. Thank you.
Yeah. Thank you, sir. Yeah. Yeah, students, now I will share the feedback link on your WhatsApp group. Just give your valuable feedback on this session. And one more thing, 3:15 to 4:15, there is a closing session at the institute level, and I will share the link on WhatsApp group. And I request each and every student to attend the closing session of induction program. Thank you. Thank you, one and all. Ramana, sir?
Yes, madam.
Sir, actually there is a question on YouTube chat, sir.
Okay, madam. Tell me.
How to join SAE?
Yeah. So due to lack of time, I could not cover. So once you join in the college, okay. So from the institute wise, so in the final year, president will be there for this student chapter. So he will collect all the forms. Or you need to fill the forms and you need to submit online. So that part, the student leaders in the final years will take care of that. So president will be there, and general secretary will be there, joint secretary will be there, treasurer will be there. So mostly one of the team member. That means there will be a core team will be there. So from that core team, one of the member will inform you. So after that, you have to fill the form, and some fees will be there, and that fee we need to pay. After paying the fee, you can join. Okay, you will get a membership card, and with that membership card, you can participate in any of SAE events. Is it clear, or anything more?
Yes, sir. Yeah, that's
Okay.
the same question.
Okay.
2 students posted.
Yeah, that's what. You have to take the membership, so that will pass through our institute only. So once you officially come to the college, that is physically, then we'll start the process of that. So you need to fill the form, and the team leaders will take that initiate, and they will complete all the process to get the membership. Okay.
Yeah, thank you, sir. And with your clear explanation of all the activities under SAE, I hope our students are very eager to join in those clubs. Thank you, sir.
Okay, madam.
Yes, students, I will share the link on WhatsApp group. Please do attend the closing session of induction program at institute level.
So please, Gautami, please inform those 2 students. So to participate through Google Meet, others will join through YouTube.
Yes, sir. Yes.
Okay, those 2 students will join through Google Meet.
Yes, sir. I will invite, sir.
మీరు సిస్టర్ ఏం చేస్తారమ్మా మీరు?
Yeah, Sanjana Johnson and Ashrit. Yep, you 2 people, please do join on Google Meet. And rest of the students, please do join the YouTube link. Yeah, thank you.